Perth Linux Users Group, talking Linux and open source.
For my day job, I work for Canonical on the Unity API team, which is one of the teams who are working on the Ubuntu phone project, which sometimes is also called Ubuntu Touch. That sort of refers to mainly to the operating system software, and Ubuntu phone, sort of the overall project, sort of to build new phones. Now, one of the questions you might have is, how do you go about building a new a new phone OS, Linux phone OS? It's actually a lot easier these days than it was in the past, primarily because of Android. We've got lots of large companies who are doing all the hardware enablement to bring up Linux on these devices, and in many cases, it's all of the SRE open source bits are available on the internet. And in particular, Google's Nexus devices make this very easy because they have a there's a website you can go to where you can download all the binary bits, because today I don't think you can really get a current phone which will run fully open source software. So usually there's proprietary software running on the baseband chip which handles the radio, and often there's a few other bits and pieces. So the Nexus devices sort of offer probably the best you can get at the moment if you're doing this kind of development. So for the Ubuntu Touch, when we were bringing this system up, it sort of started off with a stripped-down Android system. When I say stripped down, it's sort of removing most of the stuff which you would sort of think of as Android. So there's no Dalvik virtual machine, and the only bit of the GUI which we kept was the Surface Flinger display manager, which handles displaying the content onto the screen and various things like that. So basically, you just have Surface Flinger, the OpenGL libraries, and codecs, and I think some of the code to talk to the radio, to the GPS, and a few other bits and pieces like that. Then we sort of had Ubuntu running in an LXC container. So that container basically contained it. If you sort of logged in via SSH or using ADB, the ADB debugger link, it would look like your standard Ubuntu system. You'd be able to see that the packages have been installed via dpackage, and it was pretty standard. In order for the Ubuntu half to talk to the Android half, it's using a library called libhybris. So part of the problem is that Android, given that they try to keep as little GPL stuff in, or LGPL code in user space, it actually uses its own C library called Bionic, which is not binary compatible with glibc, which you're generally using. So libhybris basically it can allow a program compiled with glibc to make calls into libraries which use Bionic, and it's kind of a bit of magic, and it works, and it all kind of works. So in this initial phase, it was the phone booted into this small stripped-down Android, and then starts up Ubuntu from there, which is a good way of getting things started, but it's sort of not the end, not really the end goal. So we kind of flipped things around after this, so that the current images you'll find when you boot them up from the kernel, the main root file system you boot into is Ubuntu now, and now we've got Android in an LXC container. So again, it's pretty much the same components which are running in the main Android root file system, but now it's sort of subordinate to the Ubuntu stuff. Now, while the initial systems we were building, you would update them with the standard apt-get depackage tools. This is not really ideal for a phone. Pretty much, you've probably run into situations where you run an apt-get and it starts asking a question about a configuration file, or if you're using an RPM system, you might have found that it dumped a new version of the configuration file under an RPM new, and it's all a bit of a mess. So we followed the lead of most systems opting for full system image updates. So that requires the image to be in a known state. So we've also switched to having a read-only image. That's kind of it is working, but it's sort of a little bit hacky at the moment, because most of the /etc, for instance, is, while you sort of often think of it as configuration files, a lot of it you don't want to sort of modify. So most of that is handled read-only as well, and there's a number of bind mounts set up so that the parts of etc which you really do want to write to are redirected to a writable partition. This also means that we've made it so most of the non-standard applications are not included on the system image. So again, this is similar to iOS, Android, and etc. Now, we still do make it possible to switch on writable image, a writable image if you need it for development. I mean, you shouldn't need it for application development, but occasionally, if there is a component you want to change, it's helpful. So there is a little command. This is currently handled through a little file which you can put onto the data partition, which will cause it to be mounted read-write. Now, the big problem there is that we can't do incremental updates once you switch to write mode, because the state of the system image, it's an unknown state, so we can't sort of patch all the files there normally. So, but if you're doing this for development, it's fine, and I often do it. That's how I have my phone set up, so that each day I can I just have to sort of wipe the main system image to set it up. But in general, most people won't do that, and the phone is self-sufficient. It can download the updates itself and patch itself, and everything you'd expect from a modern smartphone. One of the other things, we didn't want to be in a situation like you have with Android, where Google sort of will release a version of Android which then gets customized by the carrier and by the phone manufacturer to run on their hardware, and then maybe that image gets customized by the carrier further before it gets out to the users. So we've set up a system so that carrier customizations, they get shunted off into a separate partition. So the base system image is going to be, the idea is to have the base system image being identical for all phones. So it can be updated without having to go through quite so much testing. It'll still need to be tested, but it won't need to build new images each time, which should make things a lot quicker to getting those things released. So the main shell on the system, it's using a new display server which we've been developing called Mir. We developed that to replace Android Surface Flinger. It's got an interesting design. Rather than being a separate daemon, Mir is distributed as a shared library, and the compositing daemon, the compositing server links Mir into it, so it's a single process which handles compositing and and window management and everything. The main shell where you'd see as your home screen is Unity 8, which is the next version of Unity 8, which is sort of a new generation of the UI we're running on desktops. The last few releases of Ubuntu have been running various versions of Unity 7, which is built on top of Compiz and X. So Unity 8 is started off as just a new shell for the phone, built with QML, but we've sort of extended it to handle tablets, and the end goal is that we'll be able to use this same code base on desktops, but that's in the future. I don't know when that's going to be rolled out. So for now, we're running a different version of Unity on the phones compared to what's on the desktop. But again, it kind of shares the design. So that's just a standard screenshot of Unity 7 on the desktop with the launcher open. So the main things to notice, you sort of got the search box. There's various results coming up as icons, split into various categories. There's a set of indicators up in the corner which tell you the status of your network, Bluetooth and mail and various other things. And along the bottom we've got switching between various categories of information. So Unity 8 on a phone, it kind of looks like a shrunk down version of that. So again, there's a search option which is now just up in the corner. You click on that, you'll get a search box dropping down. You've got the indicators at the top. Again, you can sort of drag it down to view those. And you can swipe left and right to switch between pages in the dash. And as you can see, you've got icons and standaway, and they're split into categories, and so it's all pretty much the same in that. It's sort of what you'd expect a shrunk down version of it to look like. So the icons and everything you see in the dash are handled by a components called scopes, which rather they're not directly graphical. They don't directly render on the screen, but rather just provide the data to the dash to display. Each of the scopes is sort of meant to represent a source of data, and they'll provide a set of results just by default as a surfacing results. And when you do a search, they can they'll narrow down those results, or maybe hit the web to pull results from like Amazon or whatever. And in general, we've got a fair bit more customization of how scopes work on the phone compared to how we had them on the desktop. So I've handed my phone around. If you pass it on further. If you look around on that, you'll see that the various pages of the dash, we've got carousels on the music. There's icons, various shapes. So the videos often sort of show different aspect ratio for the icons, and you can display. But in general, it's sort of one or two icons, a title and a subtitle. Now, when you click on a result, you'll get a preview, which again is customizable by the scope, which can be built up of various blocks of text, playable audio. There's going to be playable videos inside the previews, and you can have links and action buttons, and a long press on most results will cause it to activate, which will often open it up in the web browser, or for the music it might open up the music player, or videos, video player, etc. So Currently, the Scopes API is C++ or Go. We've been writing most of the scopes in C++, but we've got one of the teams is mainly proficient in Go, so we provided an API for that. We sort of look at custom scopes as one of the areas where carriers and manufacturers could provide something unique for their phones. So rather than reskinning the entire UI, they can put their own data into the phone. So I guess if Amazon wanted to just distribute an Ubuntu phone, they could have their own music store popping up as one of the scopes on the homepage, and various other manufacturers have their own data, own stores and data content they want to sell. So this is a great way of doing that. So while the base image of Ubuntu on the Ubuntu phones does look a lot like your normal Ubuntu, you're not going to you can't just sort of run a desktop application on the phone. Partly this is those applications aren't really designed to run on the small form factor. They're not really designed for touch. And also we've been pushing a different application model. So rather than spreading out its files all over the file system, since we were going for a read-only system image, each of the applications is packaged up into a single directory so that it can easily be installed and removed. We sort of invented a new packaging format called Click, which we wanted something simple. One of the goals was to be entirely data driven. So so you don't have scripts which will run during install like you get on dpackage or RPM. And the other big change we've been making is that most applications distributed on the store run under confinement. So the confinement system we've got is based on AppArmor, which is a security system in the kernel. We've got a set of modular AppArmor policies where applications can pick one of them. So the base policy pretty much only lets an application access its own data directory. They won't have access to the internet. They won't have access to any of the user's data other than what the user has created in the application. Then a phone could ask for access to the internet, but there's a limit to how much you can limit just through the kernel. So for a lot of services like the GPS, we're working via a system of trusted helpers where rather than an application directly accessing the GPS device, it'll make a call over dbus to a service which will talk to the GPS on their behalf, and that application, that service can then make a policy decision over whether the application is allowed to talk to the GPS. This might involve popping up a prompt asking the user if they want this application to do this. So one of the benefits of this is you're not sort of in a similar position to Android where you need to grant all the permissions up front. In this case, you'll be prompted for most of these privacy sensitive services. So like if the application doesn't appear to be doing anything which you'd expect to require GPS, you don't have to give it permission to do that. And if you've got an application which only uses it for one small feature, the user's never going to be asked about this permission until they actually use it. So a lot of these services, as well as handling this for services like GPS, we're also using these external services for media playback. One of the big reasons for this is to allow media playback to continue when an application is suspended. So one of the obvious cases is with the music app. You still want it to continue playing when you lock the screen or turn the screen off. So the music app isn't actually running when the screen turns off, but the media hub will continue playing the songs. So that's so you've got those dual benefits there. So the application, there's something in the title there. We've got two main programming APIs for applications. Most of the apps on the phone, which are handed around, they're written in QML, which is a declarative language for designing user interfaces in, which is sort of grew out of the Qt project, but you can use it with pretty much no C++ experience. So most of the apps you see there have got little or no C++ code. They're built. Most of the application logic is JavaScript, and the QML is just text files in most cases. Although it is possible to compile them down to a bytecode. And the other API is HTML5, and we support Apache's Cordova APIs for local web apps. This is probably better known as PhoneGap. The name sort of got changed when it became an Apache project because the trademarks weren't transferred at the same time. But this means that it's quite easy to, if you've got experience with PhoneGap, it's very easy to get your application up and running on Ubuntu. There's an SDK which provides a set of reusable components for QML and a matching one for HTML, so it's possible for your HTML apps to have consistent look and feel to the native QML ones. So in general, you should pick whichever API is going to make your life easiest. Yeah, the browser which is used for the HTML, we were originally using Qt's WebKit library, but we're now using one called Oxide, which is built on Google's fork of WebKit for Chromium. So that sort of gave a nice speed boost over WebKit, and it means we've got a library which is being updated regularly by Google as they release new versions of Chrome, and we can pull those changes right into the phone, which is pretty cool. That's, if people are interested, the developer.ubuntu.com website has overviews, tutorials, and API references for all of these APIs. So that's probably a good thing to write down if you're interested in this side. So if you're wanting to test out Ubuntu phones, Ubuntu Touch, the main supported devices we've got at the moment are the Nexus 4 and the 2013 model of the Nexus 7. The main reason we've only got those two supported models is that most developers, and we've got a lot of those two devices, and that's what most of the canonical developers are using for this work. We've previously supported some of the other Nexus devices, but we've sort of trimmed down some of the older devices, which didn't give weren't sort of as representative of the eventual devices we want to release. So in general, if you've got one of those two devices, then this makes it quite easy to use, easy to test out. Now, Yeah, the emulator, I was just going to get to that, but it is worth noting that if you do want to load up the standard images on Nexus 4 or Nexus 7, this involves wiping Android. So if you've got useful data on it, you want to back that up first. But the that install page will list all of the. It'll give a rundown of what you need to do in order to do that. Now, if you don't have those any of those pieces of hardware, there is also an emulator available. So this can run an ARM emulator under QEMU on a QEMU on a desktop machine, or we've also got an x86 build which will run in the emulator as well, which gives quite a bit better performance running on because you're not emulating the instruction set. But again, there are some issues which only show up when you're running on ARM. So if you are sort of serious about application development, it's probably good to get a device to run on it. Now, there are a few other community ports of Ubuntu to some other devices. So some people in the audience were mentioning running Ubuntu Touch on the Nexus 5, which is something we haven't sort of officially supported yet, and it sort of works for the most part, but there are some glitches which will lead to excessive battery drain, and that's part of the reason why we haven't sort of continued to support a wide range of devices. That phones are quite different from PCs, where there is significant engineering effort to get things working on each individual piece of hardware, unfortunately. So let's see. The primary hardware we are looking at developing, which we're looking at releasing, is there is two phones which were announced at Mobile World Congress back in February. Teaming up with a company called BQ, who's going to be releasing a model of their Aquarius phone, and a Chinese company called Meizu, who's going to release a version of their MX3. Both of those phones they've already got versions of them released running Android. So again, this is a case of using the hardware enablement, which was done for Android, as a jumping off point for running Ubuntu Touch. But in future, maybe we will have phones which don't necessarily use the Android layer. That if we have proper driver support, then I could potentially get rid of that. Let's see. So I guess one of the last things I was going to talk about was the development process. So pretty much all of the Ubuntu-specific components, Ubuntu Touch-specific components, we've got them managed on Launchpad, which is the software development website which Canonical runs. We sort of, when people are developing stuff, it's running feature branches, which we use the merge proposal system, which is similar to GitHub's MRs, which you've probably all seen. We've got some Jenkins hooked in, so that when people create the merge proposals, it'll go through and try to merge their branch into trunk and run all of the tests, and it'll then use the Launchpad API to give its tick of approval or say that the merge proposal needs fixing, which is kind of useful because when you've got a large team, it sort of means and you sort of got a limited review time, you generally only want to review stuff which you know is actually going to work, and this means that the developers have some assurance that the code works before they need to review it, and it can also be helpful as trunk moves forward, as other stuff gets merged in, that'll tell you that your code is broken. Now, we also use Jenkins to handle the merges into the trunk branches of all these projects as well. So rather than developers explicitly pushing up to these branches, they're all handled by robot processors. So this sort of ensures that anything on any of the mainline revisions on the trunk, it represents a working build. Now, in order to get things into the image, we also do some smoke tests. So each of the branches has sort of a set of manual tests which we can run through just to make sure everything works together. So for some of the one of the components I work on is the media scanner, which is responsible for scanning through all of the music and video and photos you have on the system. So the smoke tests I'd run would be setting up a new build of the installing the latest image on a test phone, then pulling the built packages and installing them via apt-get onto the phone, then testing out that all of the scopes on the dash work for displaying all my music, and make sure that the music app still works, and etc. And when that's all been signed off, then that'll get deployed into the archive. So everything which you see on the phone is in the main Ubuntu archive. Some of the software you can install it on a desktop. No, some of it you probably don't want to, because again, most of the core apps are targeting touchscreen devices, and they don't yet give a great experience with the keyboard and mouse. But that's kind of something which is going to come later on for most of these apps. So one of the other tools we've got is Autopilot, which essentially can automatically drive the UI. So it can synthesize your touch events, it can swipes and gestures, and part of that is running through fixed test scripts, which again could be saying to click this particular button, check to see the results, and so they can do those kind of automated smoke tests. But it can also be used in a fuzzing mode, where you get it it'll be essentially issuing random button touches on the image and swipes and various other gestures, and it'll keep on running until something crashes, and then you got a bug report. And so yeah, those are those are the main tools we're sort of using in development. So that's most of the main things I was planning on discussing. So I was wondering if anyone has any questions about it, or if, have passed around the phone and had a look.
Jenkins stuff, is that actually running it on phones?
So
using Jenkins as part of the workflow, is that actually doing any kind of testing using the emulator or on actual phones?
we do run on hardware. So there is, like, in one of the data centers, there's a rack of Nexus 4s, which I think have got a bit of hardware hooked up to the power button, so they can be hard reset, and sort of so that if things do go wrong. But in general, you can flash things over USB, and you can run things. I think most of the actual package builds, they don't run on the phones. Just trying to remember. I guess
I was just sort of curious whether or not you're actually running Jenkins slaves on the phones, or whether you're actually looking to automate the phone from a Jenkins
I think the Jenkins slaves run on a normal PC, which is hooked up to the phones. That's for some of the automated tests. For package builds, we aren't actually doing them on the phones. We've got some ARM servers, Calexa. I can't remember how to pronounce that one, but I think we've got a bunch of those which we bought before they stopped selling them, and that's used for most of the package builds, because again, there is some work to try and handle cross compiling to phones, but there is various things where it runs fast. It can be more efficient to do things on the phone, and sometimes you can't actually run the tests if you cross-compile. So there is a benefit to being able to run things native in that sense. But cross-compile is quite useful for application developers who third-party application developers won't have access to all of the Jenkins infrastructure.
So cross-compiling is actually like a required goal, sort of on the sort of the milestone.
Well, it already works.
No, I mean like for everything. Like you made the comment that you can't run all the tests, and I'm like, well, that would stop me being sure my app worked.
Well, okay. I mean, you could build the tests cross-compiling, but for some of these, like if you're writing unit tests. Often we run the unit tests on all of the platforms, so I think most of the packages I'm building they're being built for x86, AMD 64, PowerPC 64, ARM and ARM 64, and generally we're running the tests on each of those platforms. I mean, I can be fairly certain that code's working if I just run the tests locally, but I've had problems where tests ran fine on x86 and sent them to Jenkins, and the program segfaulted, and it turned. Well, this wasn't the. And if I was doing cross build, I still would have needed to run the tests to find these bugs, and I would have needed something to run them. I could run it in an emulator, but it's kind of one of the reasons for cross building is you don't really want to be doing your builds inside the emulator, ARM emulator, because that's quite slow.
Is there plans to use standardized hardware like MediaTek backplanes and so forth that's in basically like 70 or 80% of the low-cost phones?
Oh, I don't know the answer to that question. I think
like MediaTek is. I mean, a MediaTek backplane is $20. And it's standardized. All the chips are exactly the same. The CPU is the same. The drivers are exactly the same.
Okay,
and you only have to design something once, and you can fit on thousands of models of phones.
Again, it's different people in the company are really probably more involved in that bit. I'm mainly doing application development, scopes and stuff at the software layer.
So, James, with Android and stuff moving towards 64-bit, are there plans to release your Ubuntu phone at the same time with 64-bit?
Oh, I think I don't know the details of the two phones which were announced. As I said, they're existing phones. I think they're probably 32-bit ARM for now. As I said, we are building everything on ARM 64 as well. So we should be ready for ARM 64 when we get around to testing it. But I don't think the initial consumer phones are going to be 64-bit.
James, one of the interesting things with the BlackBerry phone and tablet OS, even though no one uses it, was that they had a pretty broad development environment. You could do Qt, you could do HTML5, but it also allowed you to run Android applications because it had on the file system a complete like Android install. Is there any discussion about being able to run Android applications, for example?
I think it's...
Or it's just not possible with the platform?
It's not currently possible, but it's something which could be done. Something which probably could be done. It's just we haven't put in resources to do this yet. At the moment, we've been trying to build up a software ecosystem where people can develop apps which sort of fit in with the Ubuntu look and feel for getting sort of a nice. We've mainly been focusing on the QML stuff. I know Michael Hall, one of the he's sort of a community guy, plus he does a bunch of development himself. He's worked on various tools to help people port some simple the UI components of Android apps over to QML equivalent QML layouts. So that's not a perfect solution because like I don't think we've got a Java development platform yet, so you'd still need to sort of rewire all of the application logic. But if you're writing C or C++ for your Android app with just a thin JNI wrapper to talk to the UI, then maybe you'd only have to rewrite that thin wrapper to talk to the QML UI. So there is some tools designing to try and get people over, but again, if you are writing cross-platform apps, PhoneGap is a fairly good solution. So that would give you Android, your iOS, and Ubuntu phones with very little effort. But yeah, I don't think you should expect the first Ubuntu phone apps, Ubuntu phone hardware system releases to include Android application support. Yeah.
Do you think we're much farther off seeing these in real production?
Well, as was announced at MWC, the aim is to have some of these phones released in this year. So it is getting close, and I think we're going to make that target. So I mean, it's going to happen. I believe both the Meizu and the BQ devices, they will be available. You'll be able to purchase them online, so you'll be able to buy them for use in Australia. But I don't know. I think we're sort of a bit far off from seeing them in retail stores. Yeah.
One word, one question. OpenGL.
What about OpenGL?
Does it work? Like, can I use it on top of Mir? Can I just build a game that runs as an OpenGL surface
Sure.
in there?
So I mean, we're exposing, and most of Mir is built on top of the EGL GLES and EGL libraries, which hardware manufacturers need to sort of provide for Android. So we're using those same drivers. Again, that's where Hybris comes in, because those drivers are built for use in Bionic apps. So that's bridged across, so it's available on the Ubuntu side. So I haven't really done a huge amount of the application development myself, but I believe it is possible. So
yeah, you made the comment about how the Android apps would be fairly easy to port if they were C++, and it sprung to mind that these apps are often OpenGL apps if they're C++. So if they could just talk directly to Bionic and go straight to the OpenGL, it would be very straightforward to port them.
So my understanding is that Qt's QML engine, it uses OpenGL for its rendering. So the applications are already using OpenGL to some extent. I think some people have looked at getting some game engines running on it, but again, we've sort of got so much work to do. Everyone's focusing on their own part, and I've mainly been focusing on scopes and some of the other sort of back-end API tasks which run on the phone rather than the front-end GUI.
James? With the Unity 7 on desktops and Unity 8 now on mobile phone, what sort of timescale are they looking at to try and unify those again? And is there any plan to do that?
So I believe for 14.10 there is a preview session which you can start up for Unity 8 on a desktop. So that's running Mir and Unity 8. At the moment it's marked preview for a reason, because you basically get the same launcher you see on the phone which I've been handing around, just sort of blown up. You get essentially the tablet UI, which it's mostly like the phone, but there's also some things like you can run phone applications in a sidebar down the side and another application on the left. But there's things like you won't be able to run X applications just yet. I believe the plan there is to expand the XMIR when we originally sort of worked on XMIR, which was an X server running on top of the MIR display server, this was essentially running one MIR application full screen, which is kind of not what we want. Eventually, we probably, for handling X stuff, we want to run rootless, similar to how if you're running an X server on Mac OS 10 or Windows. It's already we've already got a backend for Qt, which allows you to run pure Qt applications on top of MIR. So some applications will work, provided they don't depend on X. And there is a backend for GTK in development, which again would let you do that. In most cases, these backends sort of share a lot. Share a lot with Wayland because they both follow a fairly similar model of applications doing direct OpenGL rendering and the display server handling compositing and from off-screen buffers.
Great, thanks.
All right.
Are we going to see a day where the mobile phone becomes the computer and we plug it into the LCD?
So that's definitely one of the plans. So I mean, when we were saying that the plan is to get Unity 8 running on the desktop, part of the idea there is that you have devices which can adjust themselves to the input and output devices which you've attached to them. So we've given various demo. I don't think it's working yet, but the idea would be that if you plug a monitor in via HDMI, via the MHL connector on the bottom of the phone, and maybe have a Bluetooth keyboard, we would like to have it set up so you can have a converged device which will give you a fairly standard desktop experience out of that. There's been various other projects at Canonical which have been looking at that. There's Ubuntu for Android, which hasn't actually been released, but that sort of worked from the other side, sort of having a fairly standard Android install for use on the phone, and when you plug in keyboard, monitor, mouse, it would be running Ubuntu through a in a container and giving that access to the screen. That's I don't think that's been released yet because we were looking at trying to get some carriers or device manufacturers interested in it. Part of the reason there is that it's non-trivial to integrate that code into Android because it requires hooks into the display subsystem in order to share the graphics, because you don't want Android hooking into the HDMI, and you don't really want Ubuntu trying to drive the LCD on the phone. But it's coming, but I can't give you any ETAs.
The sort of new areas everybody's kind of moving into is TV and in-vehicle type stuff. Does Ubuntu have any plans to get there?
Oh, I don't think there's immediate plans. We have had some forays into sort of a television UI, but I don't think we've got any devices running that, and I think one of the ideas was to fold this into that television UI into the Ubuntu Touch and Unity 8, sort of have it as yet another way of doing convergence. But yeah, I don't know about any in-vehicle entertainment systems, IVI stuff.
No watches?
It's possible some people are working on this, but it's not my team, so.
Right. Thanks. Okay, great. Thanks.
This is one more.
So almost all the other mobile phone platforms start with the Android open source project so that they can get the Android apps. Is there a large app store on the Ubuntu desktop that we can leverage, or where do the apps come from?
Well, people have to write them. We've
Catch
got
22, chicken and egg. You got to have
Well,
the phones to write the apps.
people
That's
are
what
already writing the
Microsoft
apps.
ran into.
If you've got the phone, if there's a link to the App Store, and there's already a fair number on there. I mean, it's nowhere near the size of what you'll find on Google Play, but there's a lot of people who are interested in this, and there's benefits that there's some people who are interested in it because it's fairly easy to port apps from like Nokia, people who are refugees from Nokia's Migo platform, because that was also using QML for the final release. And there's Yola's got their Sailfish OS, which again is another Linux phone running QML apps. So there's
You still got to be able to sell enough of the apps to pay for the development costs. So you've got to, if there's 100 million devices installed, you've still got to sell 500,000 apps to break even.
Yeah. So again, I don't know what's for the future, but we've got a lot of people who are interested in who have already been interested in developing apps. So things seem to be moving forward, and there's a lot of the core apps are partially developed by community members. So there's already a fair bit of community involvement for this.
Is it possible to have like an Android emulator to run on it so that you can run Android apps, or is that not something they're even looking at?
I think this was asked before.
Yeah.
We don't. It's something which is technically possible, but we haven't looked at it yet. I don't know what's going to come in the future, because again, it's sort of a different part of the. It's quite a big team who's working on Ubuntu Touch, and I'm not directly working on the app programming interfaces.
Just one last one. With, as you mentioned, Sailfish and Samsung also pushing Tizen, do you think maybe it's getting a bit crowded out there in the OS world?
Oh, I don't know. I generally I'm not really in the marketing side, so I believe we've sort of got, there is a lot of people who are interested in alternatives to Android, and it's not really clear which ones are going to come through. I mean, one of the issues why some people are interested in it is the contracts. Most of the hardware manufacturers who produce Android phones are signed up for the Open Hardware Alliance, which requires any phones derived from which are built on top of Android, use the Android open source, to actually be fully compatible with the test suites and everything. So if they do want to have an alternative to Android, then they pretty much need another operating system rather than just making an incremental modification. Not everyone's sort of got the resources to do a full fork like Amazon did, for instance. Well, they've got a bunch of stuff on top of that. They've got replacements for a lot of the Google services, which. Well, they've got replacement for Maps. They've got replacements for a different store. There's a fair bit of there's a fair number of Android APIs which aren't part of Android open source, and they needed replacements for a lot of those. So in microtransactions in apps, that's not part of Android open source. There's the Maps API and various other things. So it's a fairly big job to go cold turkey with Google.
Are there any, I didn't think I saw any, but were there any closed parts in this stack? So above the Android drivers and...
So everything which you see on the phone, apart from the binary blobs, binary blobs which come from the Google Nexus website. That's all open source. It's quite possible that some carrier customizations may be proprietary, and not all of the third-party applications on the application store are open source, but a lot of them are. There's facilities, and you've got paid apps on the Click Store as well. I think the payment system's up and running now, but that's sort of that for a while everything was free, but it's generally looking at similar. I don't think we're looking at doing quite as much proprietary as Google has with Android, modern Android.
How much does the OS cost? Like if you're a manufacturer, how much does it cost?
You're asking how much it costs? I don't know. That's a different part of the. I'm not involved in those sort of negotiations.
Thanks very much, James. It's been a really interesting talk. I think the number of questions sort of shows that. So
Yep.
yeah, thanks for your time. Thanks for coming down, everyone else.